Hello friends, I am Viddya S.Patil, Assistant Professor in Department of Mechanical Engineering in Sharad Institute of Technology, Polytechnic, Yatra. Today we are going to continue our fifth unit of Refrigeration and Air Conditioning for the subject Power Engineering and Refrigeration. In this session, we are going to cover the psychrometric processes, properties of air, psychrometric processes, and psychrometric chart. Okay, we start from psychrometric properties of air. Before that, first we know what is psychrometry. Okay, psychrometry is the science that dealing with the physical laws of air and water vapor mixtures. Atmospheric air always contains water vapor, and the amount of water vapor present in air plays an important role in comfort air conditioning. So, the amount of water vapor present in air that depends on partial pressure of water vapor and temperature and total pressure of mixture. So, due to the change in temperature and pressure, amount of water vapor present in air changes accordingly. So, the psychrometry is the science which deals with the study of behavior of air and water vapor mixture is known as psychrometry. The properties of air and water vapor mixture that are known as psychrometric properties or psychrometric terms. Okay. When designing an air conditioning system, the temperature and moisture content of the air to be conditioned and the same properties of air needed to produce the desired air conditioning effect. So, in another words, we can say that the psychrometry is the study of moist air or a mixture of dry air and water vapor. Now we see the properties of psychrometry. There are so many psychrometric properties like dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity, humidity ratio, and humidity. And again, in humidity, there is a specific humidity and absolute humidity. Before that, first we know that what is dry air, what is moist air, and what is saturated air. We start from dry air. Dry air is the mixture of nitrogen and oxygen, neglecting the water vapor and other gases. And the volumetric composition of the dry air is 77% of nitrogen and 23% of oxygen. So dry air does not contain any moisture, that is called dry air. Moist air is the mixture of dry air and water vapor. The amount of water vapor present in the air that depends on the absolute pressure and temperature of mixture and partial pressure of the water vapor. So in moist air there is some amount of water vapor is present. In saturated air the water vapor present in air is known as moisture and its quantity in air is an important factor in all air conditioning systems. The mixture of air and water vapor at a given temperature is said to be saturated when it contains maximum amount of water vapor that it can hold. So if the temperature of mixture of air and water vapor is above saturated temperature of water vapor, then that vapor is called superheated vapor. So in saturated air relative humidity is 100% and in saturated air degree of saturation is equal to 1. Okay. Now we see the one by one properties. First we see the dry bulb temperature. Dry bulb temperature of air is the temperature recorded by ordinary thermometer and it is not affected by the moisture present in air. Okay, so the dry bulb temperature is the temperature indicated by the thermometer exposed to the air in a place sheltered from direct solar radiation, and the term dry bulb is added to temperature to distinguish it from wet bulb and dew point temperature. This dry bulb temperature is denoted by small t dB, that is temperature of dry bulb temperature. Next is a wet bulb temperature. Wet bulb temperature is the temperature recorded by the thermometer when its bulb is covered with wet cloth, that is known as wick also, and it is exposed to air, is known as wet bulb temperature, and it is denoted by T small t WB, that is wet bulb temperature. Okay, here we can see the wet bulb temperature is the temperature recorded by thermometer when the bulb is enveloped by cotton wick saturated with water. Okay, and the accuracy of simple wet bulb thermometer depends on how fast air passes over the bulb and how well the thermometer is shielded from the radiant temperature of its surroundings. Okay, next is the dew point temperature. Dew point, that it is the temperature at which moist starts to condense out of the air, is known as dew point. Okay, dew point is also known as saturation temperature. Dew point temperature is determined by moving from a state point horizontally to the left along lines of constant humidity ratio and until the upper curved saturation temperature and boundary is reached. It is a mixture of air and water vapor is cooled at constant pressure, then the ability of air to hold water vapor reduces and saturated condition will be reached. So the further lowering the temperature will result in condensation of the water vapor and or formation of the dew. Okay, so in a dew point, next is relative humidity. Relative humidity, here the formula is given here for the calculation of relative humidity, that is amount of moisture that a given amount of air is holding into 100, because we are calculating in percentage, so into 100 divided by amount of moisture that a given amount of air can hold in saturated state. Okay, so here in humidity there are two types, there is specific humidity and absolute humidity. In specific humidity is the ratio of mass of vapor to the mass of dry air in a given sample moist air. So the calculation of specific humidity is equal to mv divided by ma. mv is the mass of water vapor in mixture divided by mass of dry air in mixture. So it is also defined as the mass of water vapor associated with unit mass of dry air, that is specific humidity. The unit of specific humidity is kg per kg of dry air. So here we can see next is the absolute humidity. Absolute humidity is the mass of water vapor per unit volume of air containing the water vapor. This quantity is also known as water vapor density. So again here humidity ratio, a specific humidity calculation is given. It can defined as W is equal to M divided by G. Small m is the mass of water vapor and in air water mixture, and G is the mass of dry air, and is generally expressed in kg per kg of dry air. Next, now we see the psychrometric processes. Okay, in psychrometric processes there are so many processes: heating, cooling, humidifying and dehumidifying, which takes place in air conditioning and changes the air from a condition represented by initial state point on a psychrometric chart to some condition represented by another state of point on the psychrometric chart. Okay, there are different processes possible, like sensible heating, sensible cooling, cooling with adiabatic humidification, heating with dehumidification, that is also called adiabatic chemical dehumidification, also cooling with dehumidification, and heating with humidification. Okay, now we see one by one. First is the sensible heating, sensible heating and sensible cooling also. Okay, here in a diagram we can see here there is a sensible heating diagram where the inlet air is goes through the heating medium. Sometimes there is a heating medium as take as the heating coil. Okay, and inlet air temperature is small t1, and outlet air temperature is small t3. Okay, and t2 is the heating coil medium temperature. Okay, first we see what is heating and sensible cooling. Heating of air or cooling of air at the same humidity ratio, that is without any changes in moisture content per kg of dry air, that is called sensible heating or sensible cooling process. That means heating of air without any change in moisture content per kg of dry air, that is called sensible heating, and cooling of air at same humidity ratio without change in moisture content per kg of dry air, that is called sensible cooling process. If air is passed over heating coil, as here in figure we can see there is a heating medium, there will be a sensible heating. Okay, and when coil may be electric resistance heating coil, or steam is passed through the coil, or hot water is passed through the coil. Similarly, the sensible cooling, that means air is passed over the that cooling coil or that cooling medium. Okay, so coil may have refrigerant at low temperature evaporating inside the coil, and cooling, and in cooling the air flowing over the coil. Okay, we see one by one. Okay, next is the sensible cooling. We already see that in sensible cooling there is a cooling of air or at same humidity ratio without any change in the moisture content per kg of dry air, that is sensible cooling process. Okay, and in cooling process the air is passed from that coil. So again here we can see the cooling with adiabatic humidification. Before that, first we know what is bypass factor. When the stream of air passes over the coil, the part of it some part of it in direct contact with the coil surface, while remaining just bypass unaffected. So the amount of air which bypass depend upon the velocity of flow, and this bypass process is measured in terms of bypass factor. So we can if we consider the sensible heating and sensible cooling, that time the bypass factor of a heating coil, that is it is the ratio of T2 minus T3 divided by T2 minus T1. Okay, but in the in the case of bypass factor in the case of cooling coil, that time T3 minus T2 divided by T1 minus T2. Okay, because at heating time T1 is the dry bulb temperature of heating coil, T2 is the temperature of that coil or that heating medium, and T3 is the dry bulb temperature of living air. Okay, but in cooling at the same time, the bypass factor at cooling coil, that time T1 is the dry bulb temperature of entering air, T2 is the temperature of coil, and T3 is the dry bulb temperature of living air. Okay, so in heating and in cooling process, addition or removal of sensible heat without change in absolute moisture content. Okay, and also here we can see here the Psychrometry of dehumidification. Dehumidification by cooling is another term, and dehumidification at heating also. So in cooling coils, temperature of air reduces and the saturation point, okay, dew point is reached, and further cooling results in reduction of absolute humidity. The cooling with adiabatic humidification is another process where, when the air is passed through an insulated chamber and having sprays of water maintained at a temperature at higher than the dew point temperature of entering air but lower than its dry bulb temperature. So the air will be both cooled and humidified. So the process is represented on psychrometric chart also by cooling with adiabatic humidification process. Okay, and also again heating with dehumidification is also called adiabatic chemical dehumidification, where the heating with dehumidification, that is also called adiabatic chemical dehumidification, in which dry bulb temperature increases with decrease in moisture content. So air can be dehumidified by passing it over a liquid chemical absorbent which has greater affinity for moisture. Okay, and during this absorption of moisture, its latent heat is given to the air, rising its dry bulb temperature and decreasing its specific humidity. So total heat of air remains constant. So this process follows the constant enthalpy line. So it is called adiabatic. Okay. Next, now we see the psychrometric, and here the processes are given here. An adiabatic mixing of moist air and steam is also given, where the psychrometric process that involves no net heat loss or gain during the mixing of air. Okay, here we can see here the two net heat losses are given, two ways are given here. Okay, so in heating and dehumidification process also shown in this psychrometric chart, where in y-axis y there is absolute humidity and in x there is a dry bulb temperature, and saturation curve is as shown here. So now we see the psychrometric chart. In figure we can see here there is a psychrometric chart. In air conditioning purpose, the atmospheric air is to be treated and temperature and relative humidity of air is to be maintained as per the requirement. So in the design of air conditioning problems, it is necessary to know the properties of air at different conditions of air. So the psychrometric chart is the graphical representation of various psychrometric properties of moist air, like dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity, relative humidity, enthalpy, and specific volume. So the dry bulb temperature is taken on x-axis, and moisture content, dry bulb temperature is taken on y-axis, and specific humidity, that is moisture content, is taken on y-axis, on ordinate. So the here in we see here the dry bulb temperature lines are faint blue color lines are there, and for the wet bulb temperature there is a dark blue color lines are, and for relative humidity there is a yellow color line, and for a dew point there are green color lines, that are the dew point, and the humidity ratio, that lines are given as a black color lines. Here again in psychrometric chart we separated here these all lines and gives the name here. We see one by one. First is the dry bulb temperature lines. Here the constant dry bulb temperature lines, that are the vertical lines parallel to the ordinate, and it represents latent heat as the temperature remain constant along constant dry bulb temperature line. and we can read the value of dry bulb temperature on a saturated line or abscissa in degree centigrade. Okay. Next is the wet bulb temperature line. Here the wet bulb temperature line is shown in blue color line. These lines are straight inclined lines which extends diagonally, and we can read the value of wet bulb temperature on saturation line in degree centigrade. This is also degree centigrade. Next is the specific humidity line. These specific humidity lines are horizontal lines drawn parallel to abscissa, and the value of the specific humidity is marked on coordinate in kg per kg of dry air. Next is the enthalpy lines, and these enthalpy lines are the same as the wet bulb temperature lines, and to read the value of enthalpy, we wet bulb temperature lines are extended up to the enthalpy scale. So the enthalpy scale is known as diagonally above the saturation curve, and we can read the value of enthalpy scale in kilojoule per kg. So next is the relative humidity lines, that are the saturation lines that represent 100% relative humidity, and from this line many uniformly spaced curves for a different value of humidity are drawn representing different values of relative humidity. So we can read the values of relative humidity along relative humidity line in percentage, so along constant relative humidity line. So relative humidity remains constant. Next is the dew point temperature lines, the constant specific humidity lines that are also called as constant dew point temperature lines. So the constant dew point temperature lines are horizontal lines, and we can read value of dew point temperature on saturation line in degree centigrade. Next is the specific volume lines. These specific volume lines are the straight lines, and these lines are uniformly spaced over psychrometric chart giving value of specific volume in meter cube per kg. So apart from the psychrometric chart, scale is also there, and a reference points mark on it. So SHEF scale is there, that is SHEF scale is the sensible heat factor scale, okay, which gives the extreme right corner of the psychrometric chart. Okay, these are the all lines, and here we can see this psychrometric chart. Okay, these reference points also there, where reference points having coordinate 24 degree centigrade dry bulb temperature and 50% relative humidity, okay, is taken on the psychrometric chart, and the reference point is used to take the reference for calculation in air conditioning problems and psychrometric processes. Okay, in this session we cover the psychrometric properties of air, psychrometric chart, and various processes. Okay, thank you.